Okay, hello everybody. So, the first thing I'm going to do is read this question out loud. Sometimes it helps to read the question out loud before you tackle the problem. So, if the heat of combustion for a specific compound is negative 1,290 kilojoules per mole and its molar mass is 46.73 grams per mole, how many grams of this compound must you burn to release 661.60 kilojoules of heat? Okay, so this sounds confusing, right? You might be like, what is this talking about? So the first thing I want to do is ask, what are we looking for? And let's write that down. We are looking for grams. That's all you have to find. There's lots of numbers in there, but the only thing you have to find is grams. Now that I have addressed what I am looking for, I'm going to address what I already know. So what do I already know? I know that the heat of combustion is negative 1,290 kilojoules per mole. I know that the molar mass is 46.73 grams per mole. And I know that we want to release 661.60 kilojoules of heat. Okay, so now that I'm looking at this, I see kilojoules per mole, grams per mole, and kilojoules. So what I see is we have 2 kilojoules, kilojoules, and we have 2 moles, moles. What are we left with? Grams. That tells me that this is a dimensional analysis problem. So if that doesn't make any sense to you, let me just write that out. So with dimensional analysis problems, it's always easiest to start with the unit that only has one unit, with the number that only has one unit. So what only has one unit? 661.6 kilojoules. All the others have 2 units. Kilojoules per mole, grams per mole. This one just has one, so we're going to start with that. 661.60 kilojoules. Okay, now we want to match it and cross it out with something else that has kilojoules. So what else has kilojoules? The heat of combustion. And we want the kilojoules to cross out, so I'm going to put the kilojoules of the heat of combustion on the bottom so that the kilojoules and kilojoules will cross out. Okay. So that means I have to put the 1290 kilojoules on the bottom. Great. Now so we crossed out the kilojoules. Now I want to cross out the moles. So I can do that by taking the molar mass, grams per mole, and that'll enable the moles and moles to cross out. So 46.73 grams per mole. And then that all crosses out. And we get a number. So if you see here, just to say again, kilojoules cross out, moles cross out. What are we left with? We're left with grams. All right. So when we plug all of this in, and I don't have a calculator with me, so I'm sorry if this answer is not quite right, but just plugging it into my computer, it comes out to be 24.0. Well, it actually comes out to be 23.96 grams. But then with significant figures, looking at this, the smallest number of significant figures we have in this problem is 4, coming from the 46.73 grams per mole. So if we want to round this to 4 significant figures, it will be 24.00 grams. All right, and if you see down here, I should have mentioned this at the beginning, but I just put this down here for those of you who needed a quick answer, quick setup. You didn't have to watch this whole video. You could just check out the equation I set up down here. All right, good luck.